Thank you to everyone for joining us today for our webinar, AI and Cyber. Just some housekeeping real quick. Your microphones are muted and your camera is off, but if you'd like to ask any questions, please feel free to use the raise your hand feature or add your questions in the chat section here on Teams. Lastly, this webinar is being recorded and will be sent out to you afterwards. So if you have any questions afterwards, please feel free to reach out to one of us or to our presenter, Sam. And so now I'd like to turn it over to Sam Bourgeois, our Chief Information Security Officer at DYOPATH. Take it away, Sam.
Thanks so much, Charlie. Appreciate it. Welcome, everybody. This is just a kind of a very high-level 30,000-foot conversation, really, if nothing else, around AI vulnerability, how we do detections moving forward, the hype around Mythos. Is it real? Should we be worried? What can we do to respond to this? And just fundamentally, what does it really mean to security operations? What does it really mean to CTOs, CIOs, and CISOs, as well as the rest of the C-suite and operations teams? So we're going to be touching on current events, just kind of the latest. If you follow the news, you know that recent export controls were lifted just this week at the time of recording. So if you're watching this recorded, we're on July 1st, 2026. And earlier this week, we saw that export controls were lifted against Anthropic, paving the way for Glasswing to get back on track and for Anthropic to share access to some of their tooling with some different preferred vendor contractors. Also in the news, we know that Fable, which is the kind of the Mythos level, is what they're calling it, Mythos class frontier model, is going to be back on track to be open to the public as well, with obviously some significant guardrails. We're going to talk about some trends, just where we're seeing AI going, where we're seeing security going, how those two things converge now and in the future. We're going to look at objections, so things that maybe you haven't thought of, maybe some different perspectives, some different viewpoints. We're going to try to get a deeper understanding of not just what these tools are and how they're going to be used, but also how we can do security operations in the future, to provide essentially what the last bullet there is responses. How do we action this? How do we do something about this? So without further ado, I'll go ahead and begin just with just kind of a summary here. Key takeaways, if you want to call it that. So we all know a couple of fundamental things. AI is accelerating. We can't slow it down. It's an acceleration of the old Moore's principle. So if you're familiar with that principle, it was basically the speed with which we advance and the speed with which we can store data was kind of an exponential correlation there. Now I would say it's off the charts. And so the things that we can do with artificial intelligence now, with the frontier models, they are very, very impressive, and they are in many ways kind of earth-shattering for the security world, for a lot of things. Again, in the news, we saw the NSA was talking about the use of these models, and it basically uncovered all of their secrets within a few hours. It's not magic. That's the truth. It's not magic. And there are things that we can do to mitigate. Number two, old vulnerabilities. So, there's probably, 30 years of vulnerabilities that have been piling up on us. If you work in the manufacturing space, if you have, anything like operational technology, IoT, Internet of Things devices in your networks, there are probably a lot of old vulnerabilities that have been floating around for many years that were likely unreported. It doesn't mean they're new vulnerabilities. And just because this technology that we're going to talk about is finding them, it doesn't mean that we didn't have a chance to patch those sooner. It is uncovering something that we should be talking about, which is, what do we do about those old vulnerabilities? Number three, the real shift is economics and scale. It's not necessarily capability. I mean, there's some things that we could do that we have been doing for a very long time. And it's important we understand the differences between agentic AI, between automated systems using AI, and between the ability to enhance humans with better telemetry, faster automation, enriched guidance to do things that we've already been doing. There's a lot to talk about and a lot to unpack there. But fundamentally, what I would argue is this is a shift in economics and scale, not necessarily in capabilities of raw power of these devices, of these systems. AI is changing, and it's changing offensive and defensive type timelines. It's not just all the FUD we say, the fear, uncertainty, and doubt. There are changes and there are timelines that make me feel good about the future with respect to defensive operations using these AI models. And then last but not least, organizations must adapt at AI speed. So we need to, apply what I just said about the defensive timelines. We need to apply that to our security operations. So we need to adapt and we need to get our operators and our systems responding at the speed of AI, at machine speed, because that's where the attackers are already, they're already there. They're already there. They're already using those things. So we're going to talk about Mythos. It is real. Is the hype valid? We're going to talk about Glasswing. What is Glasswing? If you haven't heard of that, basically it's just giving the good guys a head start here. We're going to talk about technical debt. This is now replacing that term in my vernacular. I'm saying it's now threat debt. So I'll talk about that with you in just a minute. We're talking about software build and materials. It's no longer an option. We have to understand not only our supply chains, but we have to understand where our code is coming from, where are those repos coming from. We have to understand if we're building on the shoulders of giants in many cases. So what is that underlying technology, the underlying code, those repos, old systems that we're building on to create new modern systems? Those are going to become a risk for us in the long term. We need to talk about patch velocity. Simply put, we need to prioritize treating those risks, treating those vulnerabilities in a way that makes sense for the business, but also moves faster than humans can approve or anticipate or test in many cases. And so we're going to have to kind of rethink the way that we do vulnerability management. We're going to have to do it much faster than we have been doing in the past. And then last but not least, AI audited code. If we're using any kind of infrastructure as code in our networks and our systems, if we're doing application development, AI audited code is a must. We have to start that immediately. Best time to start was a year ago. So we gotta talk about that and address that as a business, as an industry. So let's start with the headlines. Just Mythos in the news. Where are we at right now? As I mentioned, I just read the latest article this morning. From what I understand, Fable's back on track. So we're hopefully going to have Fable released externally to consumers in the near future. Export controls, as I mentioned, have been lifted from Anthropic. That means Glasswing is back on track. If you're not familiar with that, we'll kind of unpack that a little bit. And probably some of the words that I've heard people making up now and using quite commonly are vulnpocalypse and bugmageddon. What does that mean? Vulnpocalypse is obviously a combination of vulnerabilities and apocalypse. So are we just going to be absolutely inundated, buried with vulnerabilities across our systems? And so, how do we deal with that? There are probably places and corners of our network and in our physical environments that we haven't scanned, that we haven't looked at. And the argument is, with these new automated tools, with these new frontier models, they're going to uncover all those skeletons in the closet, so to speak, and we're going to have an apocalypse of vulnerabilities that we're not going to know how to deal with. I would argue it's not just about finding them, it's about exploiting them and what is the actual implication, but we'll come back to that. Bugmageddon, kind of the same thing. Are we going to be finding bugs so fast that we simply cannot keep up? Is it going to get to a point where humans just cannot create software that's safe enough to not be cracked, manipulated, or exploited by these tools? I think the answer is yes. What is it claimed? Well, one of the big headlines that I think captured a lot of folks and their imagination was this BSD kernel vulnerability. It's not necessary that you understand technically what that means, but what it basically purported was in the news that there were thousands of potential 0 days, and this one kernel vulnerability made the headlines because it was like, humans have never seen this. It's been there for 27 years. It was hiding in plain sight, and this AI found it, snap of a finger, and we're all in trouble. That's kind of the headline. The truth is that vulnerability was not necessarily something that people couldn't find. It was just something they weren't maybe looking for. And so I would say we got to kind of shift and adjust our perspective on that and start thinking about things a little differently. Perhaps we have to start thinking about how do we incent the behavior we're looking for. So if we as an industry, as a market, if we're not incenting people to find those vulnerabilities, then why would somebody do the work to go out and actually reverse engineer and do the analytics to find those vulnerabilities? That's the real question. So we have to kind of translate that into economic terms and say, well, if I could pay someone to walk through my neighborhood and jiggle all the locks to see if anybody left their door unlocked at night, yeah, sure, I could accomplish that. But who's got the money for that? Who's got the bank account to pay those folks to walk around and do that? That's kind of the same question with these vulnerabilities. Humans have not traditionally just knocked on doors virtually and looked for these vulnerabilities in literally everything around us. Now we have to kind of understand and we have to kind of compensate for the ability to turn these machines, the AI, loose on these systems to go and jiggle those locks virtually, as it were, and check all the vulnerabilities in code and in systems. So that's kind of why it matters. Microsoft, the kind of the big kind of 800-pound gorilla in the room. Most of our customers at DYOPATH are using Microsoft. And so, we kind of had this question answered many, many times in conversations. We say, is Microsoft safe? Can we depend on our standard tooling? Can we use the applications that were provided, or are they going to be at risk? And if so, what do we do? Like, how do we even operate? How do we just do business? And one of the challenges that we have is that Microsoft tools, especially security tools, they are powerful, but they're complex to run. They're difficult to manage. They're difficult to configure and harden. And of course, you have to watch them. So these are some of the kind of the underlying conversations that we have frequently, that I have personally quite often. And the perception that we have from all of this is that AI is outperforming decades of human research, and it's just infinitely better than a human could be. That may not necessarily be the case. Like there's definitely a lot to be said about enhancing, and this is definitely going to change the game for sure, no question. But there is a lot of hype. So let's see if we can kind of cut through that a little bit. The big ones that I do agree with that are kind of game changers is one of the percentages, approximately 72% of the autonomous exploits were successful. That means essentially you didn't have to know how to code or know how to hack or anything. You could just kind of say, hey, here's the system, find vulnerabilities, exploit those vulnerabilities, et cetera. And 75 and down into the 60% range is what I've read in different reports, claim that the autonomous exploitation was successful. That's a big deal because that is leaps and bounds better than the previous models. The previous models were significantly lower than that. So we are seeing a real delta shift, a real change in terms of efficacy and the power of these machines, not to just do the things faster or better, but to actually be successful. That's the challenge. If you ever try to generate an image with AI, you know what I'm talking about. You can have the same clear prompt, put it in 3 different models, and they'll generate, some will be junk and some will be good. And you can say, recreate and try to clean up this image or quantize this or move this or remove pixels from that. And it's kind of hit and miss. That's kind of how AI was looked at in terms of finding vulnerabilities in the past prior to Mythos. Now what we're seeing is just again, a huge, tremendous shift in terms of that efficacy and actually being successful at finding not just vulnerabilities, but exploiting them. The cost that I've read about was about $2,000 per vulnerability. That's also interesting. We should think about those from an economics perspective. How much is this going to cost? So if we're spending $2,000 per vulnerability and we're finding vulnerabilities that really don't have any exploitable value, they don't really impact businesses, there may not be the economics behind that to actually want to do that in a broad scale. There may not be enough money, tokens, et cetera, to really go out and do that across the board. What it does mean is that we could have potentially targeted attacks at specific networks to find those vulnerabilities, and that's where the economics come in. Are we going to find every vulnerability everywhere? Probably not. Like that's going to take a lot of compute, a lot of tokens, a lot of cost to do that. So I think that's something we have to keep in mind as well. There was a great quote that I found from Dario, and basically just kind of a summarization for you is we have kind of a 6 to 12 month window is what he talked about to find and patch critical vulnerabilities that we think are going to be most impactful to the majority of U.S. businesses and users. And after that point, once this gets out, once this is leaked, once this is released to the masses, we have to expect that other competitors, whether it's a CCP or DPRK or a Russian GRU, they're going to have those same capabilities. And so how do we do that? How do we get early access to the good guys, as it were, to try to patch those things, to try to fix those things and protect consumers? So I will say there has been kind of water cooler talk. I've read a couple of reports, even in Reuters, that this was potentially leaked to third parties. So whether or not it's already out there is open for discussion and debate. My instinct tells me it probably already is out there beyond the scope of Glasswing, but we'll talk about Glasswing in a second here when we get to that. But really, what I wanted to kind of hone in is that distinction between discovery and disclosure, and something that I think probably a lot of folks watching this may not be aware of, and that is kind of the market for vulnerabilities and the market for bug bounties and the market for what we call 0 days. If you're not familiar with that terminology, 0 day means you have 0 days to patch. So it's a vulnerability that's been made known, and there is no patch available. So there's 0 days to plan for it. The best book that I can point you to, or if you're curious about learning this, even as a layperson, the best book that I can point you to is this is How They Tell Me the World Ends. It's a Nicole Perlroth. She came from New York Times, chief cyber reporter. Fantastic book, and it really does give you a really great picture and a great foundation for how to better understand how this market works. So that's a great one to point you to after this webinar is over. You can go find that wherever you like to buy books or listen to books. But essentially what those 0 days and those bug bounty programs and other things like that, essentially what we're talking about here is we have had a long history in the field, from the US perspective, the Mossad perspective, the Russian GRU perspective, whatever the case may be. We have a long history of finding vulnerabilities that are fully exploitable that could hurt our own citizens. So you have the NSA, let's say, and we find a vulnerability with Microsoft. Well, the NSA is not going to go tell Microsoft about it because they want to exploit that vulnerability to maybe extract information from our enemies. So exploiting that vulnerability on a machine sitting in Moscow is worth more to the NSA than sharing that disclosure with, say, Microsoft to patch it for the whole world to get an update out to everyone. And so that's kind of, in a nutshell, how this vulnerability disclosure kind of marketplace works. In other cases, we have bug bounty programs where an ethical hacker might find a bug in a system, and they will go to the Microsoft webpage and they'll kind of fill out a form, and they'll basically say, I'm willing to tell you about this bug, about this anomaly, about this thing I found. And Microsoft has published kind of catalogs around how to pay out those folks who find those vulnerabilities, bug bounty programs. Now, what I wanted to kind of talk about is that distinction between undiscovered vulnerabilities and undisclosed vulnerabilities. What we don't know is how many vulnerabilities has the GRU, the DPRK, the CCP, or the NSA, how many vulnerabilities have they been sitting on for the last 25 years? Do they have a vulnerability for my thermostat, for my smart TV, for my refrigerator in the kitchen? Probably, they probably do. So it's not a question of, are these vulnerabilities unknown? It's a question of, how are these vulnerabilities going to be used against us, and how do we get disclosure to the larger population? And that's really again a question of economics. It's also a question of politics. And so I think what one undertone of this kind of conversation around mythos level, what we're calling it, or frontier models that have this much power, there's a kind of an undertone, a conversation that needs to be had around, this is kind of a democratization of vulnerabilities and a democratization of vulnerability disclosure. really. And so these high value bugs like a an RCE from the kernel, these might go for $100,000, $200,000 if they're sold to brokers, if they're sold to the Emiratis or the NSA or whoever it was. And so those bugs were never reported in the first place. If the question is how many threat actors are going to use this new model to find those vulnerabilities, the question has to be asked, well, what do they do with it once they've found it? Because we're going to dilute the market downstream. If we sell those vulnerabilities to the NSA and now the NSA has it, the NSA has to kind of assume that this person who disclosed it to the NSA or brought it to the NSA has probably sold it to someone else as well. And so again, it changes the politics. It changes how we respond to this downstream. That's again an interesting nuance. We have to kind of see where that unfolds in the future. And so my conclusion, my insight there is that AI might be surfacing known but hidden flaws. They may not be doing anything that's impossible for humans. They may just be kind of exposing it in a way that we haven't seen before. And so that's one of the insights I wanted to share with the group here. Why do bugs stay hidden? Well, we talked about this a little bit, but just to kind of give you a little bit more data, the BSD bug that we talked about earlier, the 27-year-old bug, there's no bug bounty program, so there was no incentive. So if a human found it, they might have found it 25 years ago. They might have found it 5 years ago. We wouldn't know because there's no bug bounty program on that particular. There's no market for it, right? There's no one to tell and get money for. So why would it be disclosed? That's the question. Without that incentive and without creating incentives in the future, my fear is that we're not going to audit code publicly. We're not going to report those findings responsibly. So it's actually exacerbating an existing problem, which is we don't have enough bug bounty programs. We don't have enough incentive for folks to find those things, expose those things, and then to responsibly disclose those things. And that means that for skilled researchers, I mean they're working for peanuts essentially for bug bounty programs unless there's a greater incentive there. They're investing decades and decades of experience. You've got malware analysts, et cetera, that know how this stuff works, and they're incentivized to find the programs that will pay out, not to find BSD kernel vulnerabilities that don't pay any kind of bug bounty. There are folks who do that. There are folks who disclose those things and share those things. But the implication that I kind of wanted to share is that many eyes do not necessarily mean many skilled, incentivized eyes. So just because there's, say, an open source application or maybe a code repo that everyone's building on and using, it doesn't mean just because everybody can see it, it's safe. It doesn't mean just because everyone has access to it that we can find those vulnerabilities and disclose those. It just means that everybody can see it. And so my fear is that AI is going to be turned loose on those repos, on those open source code libraries, on open source tools and applications, and that's going to cause a lot of downstream risk for organizations because they may not be aware that code repo or that source code or whatever the case may be part of its supply chain. We may not even be aware of that. There's a lot of businesses that use open source foundations and then build upon them to create products and services. And without an understanding of that supply chain, I think that's where we're going to have a lot of risk in the future. So that again, that open source security myth, what's true? The code's visible. What's missing is that economic incentive to review and to really to prioritize it. And that's where I hope we can flip the script from kind of the fear, uncertainty, and doubt of mythos scanning all these things. My hope is that we can flip that around, and that the good guys, the blue team, will be able to use these frontier models and do more proactive, preventative work with the models we already have, with the tools we already have, and maybe with these frontier models like Fable, to scan those things and to improve those things. And it's going to take the whole community coming together to do that in many cases. We have a lot of open source code repos and open source tools that aren't really maintained today. And we don't talk about that because it's never been a problem before. It's never been an issue. But those open source repos, those open source that source code, those are going to be a source of vulnerability for literally everybody downstream who's using those foundations. So we have to kind of figure that out. That's what's missing. An example, shell shock, bash vulnerability existed for about 25 years. It's really not that complex, really not that big of a deal. But the problem is it was probably seen by thousands, millions of people. It just doesn't mean that they reported it or that there was even any place to report it. There was maybe nowhere to go to fix it, right? So that's what's got to change in the industry. And a good way to summarize that, to kind of give you some actionable next steps here, we've got to find ways to leverage the tools we already have to do code review, to do vulnerability discovery on our networks and systems. We've got to look at networks and systems that we haven't maybe thought of looking at before. Oftentimes, folks will do, let's say, vulnerability scanning on assets that they already have under management. That means you might do all the scans on laptops in your environment, but did you scan the actual network? Did you look at the IP clock on the wall? Did you look at the Honeywell thermostat on the wall? Did you look at the Johnson control panel up in the attic? Those are the kind of things we're going to have to start looking at differently in the future. And once we discover those vulnerabilities, we're going to have to start thinking about how do we expedite the treatment of those risks? How do we patch faster? So exploit development, I think in the future is going to be something that is going to be automated, and at scale, it's going to be faster than humans and certainly lower cost than human labor in many cases. It's just a matter of where do we point it, or do we use it across the board? Key points: AI didn't do the impossible; it did the undesirable, but at scale. That's the takeaway. So, traditional, we have exploit developers, we have malware analysts, we have red teamers. They work on a piece of equipment, they work on a chip, they work on a circuit board, they work on a particular operating system. They learn for years, they go to university, they do tons and tons and tons of work over decades often to find those vulnerabilities. And AI, it appears, is going to help the people who don't have those skills, or maybe they do have those skills, to do that faster and for cheaper. And so the result is that barrier to entry for attackers is going to drop significantly. Exploit development is going to be industrialized. And what we already see in the industry, which is ransomware as a service groups, exploitation on a massive scale, particularly on education and healthcare markets, we're going to see that exacerbated at scale. It's going to become more industrialized, more formalized than it ever has been in the past. That means ransomware as a service groups who already have HR departments, help desk groups. They sell their services almost like a channel partner program, where someone who has no skill but has a lot of targets that they know of can purchase that as a service, and they have ransomware as a service. What we're going to see is that's going to grow, and my prediction is we're going to see that being exploited even at the consumer level. And so I think people are going to start seeing a micro ransomware, a micro exploitation trend in the near future. I think 2027, we're going to see households, we're going to see individuals that are going to be exploited the same way that businesses have been exploited in the past. That's a fear and an unfortunate prediction that I'm going to make today. So what should security teams do to prepare for this? Let's talk about Glasswing. So Glasswing is the code name of the project. Essentially, what Anthropic did is they went out and found some of the best security partners and some of the folks that have the biggest footprint in the market. They partnered with them to develop a program to utilize these frontier models against their products and services. And the hope was that they would close those gaps, close those holes, and prevent the bad guys from having access to these models before the good guys could run all their code through it, could run their OSs, and could scan against it from external, from perimeter, et cetera. The end result, I've had some conversations, I won't say with who, but I've had some conversations with some of the big players. Think Cisco, Palo Alto, CrowdStrike, Microsoft, Google, Amazon. I've had some conversations with folks in those circles, not directly involved with Glasswing, but definitely peripheral, that have knowledge of what was happening. I have heard from one individual that their vulnerability program, when they develop a new OS to release to their edge devices, think a route switch, firewall, that kind of thing, that their exploitation using this new tool was a little more than 7 times faster. The cycle was about 7 times faster than it was with humans in the past. Think code review, think uncovering potential vulnerabilities, etc. So translation, these folks who used to do, let's say they used to release a new OS with a new patch, maybe quarterly, they're now doing it 7 times faster with this model. That means that assuming that the good guys have access to these tools, we're going to be ready when these models are released. But again, my argument is, will we ever be ready? Because can we not just improve these vulnerability finding and these exploitation tools? Can we not improve them faster than we can release new versions? That's going to be a challenge. What do we do about this? How do we address this? How do we kind of rationalize this? The first thing that I put on the screen here is technical debt is now threat debt. So let me tell you what that means. In the industry, from an IT perspective, you've probably heard technical debt. And what that really means is we've got an old PBX in the wall back in the server room. Maybe we have a server 2012 running in the environment. There's no patches available for it. Maybe we've got 7-year-old laptops. Those are all what we would refer to as, technical debt. What I'm saying is that's now what we need to do is kind of reframe that in our minds. That's going to be threat debt. And so by threat debt, what I mean is all those things that were, that there are no patches for a lot of, IoT systems, OT systems, and plant process technologies. Think electrical grids, things like that. There simply are no patches. A lot of these systems, you put a chip out there and that's it. There's no update for it. Other systems like maybe medical technology or oxygen machines, pumps in a clinic, things like that, the company might have sold or the company might have folded, and the technology is just exists. There's no new patches coming. All of those things need to be enumerated and they need to be managed from a risk perspective, and that is our new technology, our technical debt. And I'm framing that as threat debt because those are real threats to our users, to our organizations, to our business. Number 2, software bill of materials, SBOMs. If you haven't heard that term, put it in your lexicon. 2027, we're going to need to start keeping track of our SBOMs. So software bill of materials are going to be very, very important to us in the future because that is the roadmap on how attackers are going to compromise systems in the future. They're going to be looking at that code repo. They're going to be looking at the fundamental source code that you've built your technology on. They're going to be looking at the tools and the components that go into laptops. They're going to be looking at all those things. So that software bill of material, think of that as like a microcosm of the supply chain. I think that my prediction for 2027, we're going to have stronger regulatory controls on SBOMs moving forward. We already kind of see where we've gone in the defense industrial base. Now we're looking at GSA updates, and we're looking at proposed new FAR rules that take into account supply chain risk, similar to CMMC being used across the government space. And I think SBOMs are going to follow that pattern. That's going to be a trend that we're going to see trickle down into our systems, into our software development life cycles, into our procurement, into our devices even. So those are all things that I predict. Patch velocity is going to become critical. By patch velocity, I mean the speed and the automation behind remediating vulnerabilities. So that's the patch cycle. The AI-assisted code review is not going to be a convenient thing anymore. That's going to be expected. That's going to be a requirement. That's going to be something we have to do moving forward. The AI-assisted code review is something that we can do potentially with these models. It's something we can potentially do with third-party tools. It's something we can do with partners, with managed services. So there's really no excuse to not do this. It's just a cost, and it's going to become a cost of doing business. So your CI/CD pipeline, software development lifecycle, all those things are going to require some additional functions be built in. And again, there'll be costs, but it is what it is. It has to be done. And this capability will proliferate. It's going to just continue to grow. There's nothing is going to slow it down. It's going to speed up, if anything else. So that IoT legacy, I come from a background of, kind of the Gulf South, a lot of petrochemical, a lot of, plant process technologies, things like that. Some statistics for you, again, not to scare anyone, but just to give you some statistics. We've got, about 25 billion IoT devices globally. That means Coke machines sitting on the corner with an IP address. That means a switch that turns your air conditioner on or your heat on based on the thermostat, based on the temperature. Whether it's something in your consumer space, in your house, or in the plant that serves, our petrochemical needs, or on the electric grid, all those things, 60% of them are running vulnerabilities that are greater than 2 years old. 60%. So putting that into perspective, what's our risk footprint looks like? What does that actually translate in real world terms? And the answer is 60% of all those systems are going to be vulnerable. Are those systems in our power grid, in our water? Are they going to affect our critical infrastructure? Are they in our schools? Are they in our homes? We're going to have to figure that out. That's the challenge. So the reality is some of these systems, many of these systems actually cannot be patched. They will never be updated. We have to kind of reframe our mind, and our strategy has to shift from how do we fix these vulnerabilities to how do we contain the impact? How do we limit the blast radius? So not just the speed that we were talking about for patching and vulnerability management, but also the speed to contain. And do we have some kind of compensating control? So compensating controls could be something that we can build or isolate. There's a trend in IoT systems, in particular in manufacturing. We call it microsegmentation. So are your networks segmented? If there was an exploit or something happened in this particular part of your network, could we contain it? Could we isolate it? Could we limit it from harming some other part of the network or users elsewhere in the network? So the defense strategies that we're using today are not going to work long term. That's kind of what you're hearing from me. And so that traditionally relied on patch windows. And I mentioned, quarterly, that's a very common cadence for patching, updating devices. There were a lot of complex barriers. There was a lot of technical expertise that was required to do those things. It was a manual effort. AI is going to remove some of that friction. So the good news is we can employ some of these tools and technologies in things like SOAR, security orchestration, automation, and response. We can deploy automated patch management, automated vulnerability management, and that AI enhancement is going to remove some of that friction. And so we have to kind of balance that. We have to kind of understand that it's going to help the bad guys build exploits faster, but it's also going to help us to automate responses theoretically faster too. So we need to start thinking about how we're going to govern that blue team AI, how we're going to govern it, how we're going to put guardrails up, how we're going to make sure we have a human in the loop for important decisions that need to be made, but also how we're going to just pile it on. We're going to do continuous scanning. Is it appropriate to do a penetration test once a year? In this day and age, I think not. I think a static penetration test is probably valuable. There's a lot of things that humans can do that maybe the AI cannot do. But I would argue if you're going to talk about a trade-off, I would much rather have a pen test from an AI bot happen every single day for 365 days a year than a human test me one time and report vulnerabilities that I could resolve, but I won't know about the next one until next year. So we got to kind of reframe our mind around how we do that. Those attack timelines are going to compress with AI. Defensive models are going to have to evolve. And I think our compliance obligations are going to evolve too. I mentioned some of the changes with GSA, some of the changes with CMMC coming down the pipes. I think our defensive models and our compliance models are going to have to adapt. So legacy systems are now high risk. Faster exploit development life cycles means that we have to respond faster than ever before. Our vendors have to respond faster than ever before. And we have to understand our third-party vendor risk management. I would even say our nth-party vendor risk management better than before. We cannot depend on just saying, we have a contract with vendor X, and therefore it's vendor X's responsibility to keep me safe. We can no longer do that. We're going to have to start thinking further down the food chain, as it were, the supply chain. Increased likelihood of attacks that are chained together. So not supply chain, but we're talking chaining together multiple exploits. This is really important because I have this conversation so frequently with customers and partners. The the use of vulnerability scanners that has traditionally been very common. Uh, Fill in the name any vendor, any common tool that you might use. Vulnerability scanning in and of itself is kind of a flawed model because, in my opinion, if you cannot string together multiple vulnerabilities to demonstrate an actual exploit that impacts the business, my argument is you haven't really proven anything is wrong. A vulnerability 3 layers deep in the network is just that. It's a vulnerability. It's not exploitable. It's not an actual risk to the organization because there's a very low likelihood of that being exploited. AI is going to change that formula. AI is going to certainly play into that formula. But what we need the blue team AI, the autonomous penetration testing tools like that. We need that to do that exploitation for us and show us proof of concept. This is how you could be vulnerable. And then we can actually take some human action to resolve that. We can automate some things. We might have to re-architect other things. We might have to train our users. We haven't even talked about AI being used in deepfake, et cetera. Those are all advancements that are happening in parallel as well. So we have to reduce that time to respond, and that's where AI can help us. So some strategies that I recommend: segmentation. We've talked about that. Reduce the blast radius. Just plan for something to happen. It's not an if, but a when. Segmentation, zero trust principles, accelerate the response and the detection. If you're not using some kind of autonomous functionality in your security operations, we'll talk about what we're doing at DYOPATH. Our tool is called Sentry AI. If you're not doing some kind of AI automation, I strongly recommend you start looking at that. At a minimum, look at some autonomous workflows. Look at some high likelihood and common events that are plaguing your networks, plaguing your systems, plaguing your users. And how do you automate responses to that? How do you fail to a safe point? Our goal in DYOPATH is to try to get our response times as close to zero as possible. Meaning, how do we respond instead of 30 minutes? How do we respond in 30 seconds? And then we're going to keep shortening that timeline. Prioritize your patching. Look at risk-based remediation, not just strict vulnerability scores, not just CVE scores. Look at what's actually exploitable. AI-assisted reviews, especially in your CI/CD pipeline, in your development of infrastructure as code, et cetera. You've got to look at that continuous auditing of code and configuration. So, can we fix every vulnerability? The answer is no. We can't. Even if we wanted to, we couldn't. And if we could fix it, could we fix it fast enough that it won't be exploited? The answer is probably no. The question really should be, how fast can we detect and contain exploitation when it happens? If we can reframe and we can realign on that point, I think that's where we can really affect changes, and we can take our security operations and take security to the next level. My view, in summary, to kind of close this out: Mythos, it's not magic. Yes, it's scary, but I would argue that there's a lot of super, super, super powerful, really potent, well-trained LLMs that are dangerous. I got to tell you, there's some good guys out there that do amazing things with their products and services, but they do it for good. Autonomous penetration testing is a must. That's a great example. They've got LLMs that can exploit probably faster than many of the tools that you read about on CNN can cause harm, and they're well trained. It does not prove that humans have failed for the last 27 years with the BSD vulnerability. What it does prove is that AI can scale security research dramatically, that the economics of cyber defense are going to change dramatically. And the bottom line is more vulnerabilities will be discovered. That's a given. More of them will be exploited. They're going to happen faster than ever before. And if that trajectory holds, whether it's 3x or whether it's 10x, we've got to start planning accordingly. We've got to start taking action. We can't just, kind of be worried about it and say, let's just shut everything down. We're scared, right? In the short term, look at your patch timelines, look at your containment strategies, do your tabletops, think of some new innovative tabletop scenarios that have some of these potential exploits in mind, these vulnerabilities in mind. Really put your thinking cap on and think outside the box and say, hey, let's plan for this. Let's plan for this. What if this happened? you got to really shift because it's hard to put yourself in that future facing mode. But give it a try and think about some of those forward facing risks from things like Mythos and tabletop them, see how they go. Next, I would say, look at your legacy exposure. Look at that, what we used to call technical debt. Reframe that to your leadership as this is threat debt. Put some dollar signs on that. Run that through a fair analysis and see if you can come up with some numbers. Maybe that helps, right? Put some dollar signs and kind of quantify that risk. What does it look like to have all these antiquated systems on our network, unpatched systems on our network, things like that? And then do yourself a favor and implement some AI augmented detection, some autonomous SOC agents. Look into some tools that can kind of playbook some things. You may not need a fully autonomous security agent. Maybe you just need some simple automation from the tools you already have. We can help with that as well. And then, of course, if you can, find a good trusted partner that can help you to really build a customized autonomous response functionality that really is comprehensive and meets all of your needs across the organization. So with that, thanks so much. I know we have a couple of questions in the Q&A. Let me see if I can pull those up.
Yeah, Sam, our first question is, how does patch testing come into this? We want to avoid the Microsoft CrowdStrike issue of 2024.
Yeah. Yes, that's a tough one. I mean, the challenge is, you can't make an omelet without breaking a few eggs. And I think we have to kind of establish what those parameters and what those guidelines are, agree to those things and understand what the risks are to the organization, and then accept those risks and build those playbooks with that in mind. We have to be very specific. We have to scope it very, very specifically. So a great example, the CrowdStrike example, that wasn't AI, that was something else. But if you have a rule that says, if we see unusual O365 login, new IP address from a VIP at 2 o'clock in the morning, we're going to lock the account, disable all sessions. Well, guess what? That's going to really tick off the CFO if they're planning for a last minute presentation the day before at a conference. So those kind of things we have to plan, and we have to playbook that all out, and we have to say, hey, let's take this all the way to the end. And let's say when this happens, if we do have that, we've got a human in the loop that makes that decision. So for VIPs, maybe we interrupt that process and we said it's too much risk. For VIPs like our CFOs, we need a human in the loop. Someone has to click the button to disable the account, revoke all the sessions. Otherwise, we could have some grumpy leadership. That's a silly example, but the point is we have to basically just think through the entire cycle of that decision and make sure that where appropriate, we have humans in the loop to make those critical decisions, and we never take them out of the loop, because that's where I fear, all jokes aside, about Terminators and everything, but that's where I fear if we start pulling the humans out of the loop, that's where I think we have a real problem. My personal favorite solution is let's automate all the boring stuff. Let's get all the noise tuned out. Let's get the AI dialed in for the tier 1, maybe the tier 2, and then let's just enhance what the tier 2s and the tier 3s are doing. Let's make them better at their jobs, and let tier 3s, tier 2s, whatever the context is, whether it's NOC or SOC or GRC, doesn't matter. Let's let them have more human conversation, more time in conversation around how to protect the business, what the business actually does, what the users are doing, get to know the behaviors, improve the holistic approach from the security program, and let the AI take care of the noise. Let them take care of the automated stuff there. I know the question was probably specifically around patch cycles. I think for patch cycles specifically, there is a great deal of risk when we have, let's say, a critical vulnerability from an application. And what I just proposed was that we automate that critical vulnerability and patch it immediately. What we didn't talk about is what's the impact to the business. What if it breaks something? If you're in the manufacturing space, what if your computers can no longer communicate with your CNC machines, your routers, your pumps, your ventilation, whatever the case may be. So I do understand that, and I think that's where those automated patch cycles, we have to have a very healthy conversation around risk management in the enterprise and make sure we understand which of those systems are permissible and what's the risk of automating those processes. And then maybe we have to talk about how do we get humans' eyes on it more often. If we can do a human in the loop, great. If we cannot, at least let's have a mitigation plan. Let's have an incident response plan for when we accidentally patch too fast and break things.
That was great. Can you also please expand on the concept of autonomous workflows?
Yeah, so I think there's a lot of great stuff out of the box today. I'll give you an example. In DYOPATH, we've invested heavily in yeah, thank you. Shift left. Thanks, Tom. That's exactly what I'm talking about is shift left. I'll clarify that. Tom just reminded me of it. But what we've done is we've really taken a hard look at, okay, what do our customers all have? Yeah, 90 plus percent are going to be using Microsoft. Microsoft has an autonomous thing, don't they? Yeah, they do. Don't they already have tools that do defend the endpoint better? Yeah, they already have that. So we've really been having conversations like that and asking ourselves really hard questions. Why do we use CrowdStrike or SentinelOne instead of, say, Defender? Well, Microsoft is hard to build, it's hard to baseline, it's hard to monitor, manage, care and feed, et cetera. Those are all real challenges, but couldn't we maybe solve those problems with AI? And so that's the approach we've taken. We've thought about like, hey, how do we automate responses in Defender that don't cost our customers a penny more for additional software to be loaded on the machine? How do we automate that function that already exists in the ecosystem they're using Defender? That's good because from a compliance perspective, we don't have more tools on the machine. We don't have more vendors in the ecosystem. We don't have more compliance checkboxes and questionnaires to send out. That's great. But oftentimes the vendors have autonomous tooling that doesn't necessarily see the full scope of the incident or the full scope of the system that we're talking about protecting. And oftentimes it's expensive. In the Microsoft case, it is quite expensive at the enterprise level, at the user level. So what we've done is we found ways to bring in the, let's say, the DIOPATH custom LLM operating in our foundry, and then we assign custom agents specific to our customers, and we do that at scale and at cost that's significantly lower than what the vendors might propose. So we have some really innovative solutions around that, and I'm really happy with where we're at today with some of those cutting edge tools and solutions, particularly the Sentry AI, and we're looking to grow that. We talked about a large percentage of our customers are using those or have Microsoft, for example. But what about the Google people? What about the Linux people? What about the old server people? What about the on-prem people? We have to kind of address each one of those use cases and build that automation functionality across all those use cases to really benefit all of our customers. That's going to take time, unfortunately.
And Sam, I've got one more question for you, which is how do we justify the new security investments when we haven't experienced a breach yet? Like, how do you justify it to leadership?
Great book. Super. Okay. If the author listens to, I'm so sorry. I apologize in advance, but it's a very boring book. Puts you to sleep, but it's got some great details, some great juicy tidbits. It's called How to Measure Anything in Cybersecurity. And it opened my eyes to kind of some of the opportunities to find ways to create metrics around things. And so for example, what I think we don't talk about is we don't apply the basic economics of, say, fire casualty insurance. We don't apply those same economic principles to cybersecurity. If we did, it'd be a straightforward solution, right? Like we have numbers and you pay fire insurance because I'm just making this up, statistically, every 25 years, someone's going to have a fire and it's going to be catastrophic and there's going to be this much loss. And so we account for that loss and we distribute that loss, and that's what insurance is. I think we have to kind of take that similar approach, and we have to start thinking about those things. We have to calculate those vulnerabilities, calculate that threat debt for the organization in a way that's creative, but also meaningful and has foundation in USD, because that's what everybody cares about is dollars a lot of times. And so I think the balance there is, yes, go out and find tools that can help you solve problems, but don't do it just looking for the shiny object. Don't just do it because you're looking for the coolest, newest thing. Think about it from a real risk perspective. And this is, again, where AI can help. Think about what are those catastrophic outcomes that we're fearing. Get an assessment done. Get a risk assessment from a third party. Let them point out all of those weaknesses in your systems, your people, processes, and tools, not just in the tools, but across the board. And then quantify those in creative ways and say, here's the worst case scenario. And I think you don't have to try too hard, in my experience, to find those things and understand what those risks are, those catastrophic risks are. I've read the IBM State of the Breach report every year for the last, I don't know how many years. I'm sure folks in the call are familiar with these numbers. They seem extraordinarily high, but statistically they're true. We're talking millions of dollars in terms of average cost of a breach. We're talking the number used to be 170 days of dwell time before you even find something that was out of place, meaning the bad guys were probably in your network for 170 days before you ever found out they were there. Those statistics are changing. They're getting better. They actually are improving with the last report, by the way. But my point is understanding those fundamentals, and you can make a case and say, this is the risk of our organization. If it's a catastrophic failure, force majeure kind of thing, it's the same principles as if there was an earthquake, same principles as if there was a cyber incident. And so quantifying those numbers, getting some statistical data, it's all out there. And then presenting those to leadership in a way that makes sense and saying, look, we're going to invest in this. We recognize that it's going to happen. This guy, Sam Bourgeois, got on TV and he said it was not a matter of if, but when. So he promised me it was going to happen. You say that and you say, look, here's the cost and here's what we expect that implications to be, the liability to be. And here's what I want to invest in the future. By the way, this is going to protect not only our business and our funds, our revenue, but it's also going to protect us as people, because that's a whole nother element. There is the CEO doesn't want to get exposed in the dark web. They don't want their personal finances to be exposed. A lot of those tools, we can bridge the gap in understanding by bringing it a little bit closer to home and telling people, look, we care about you personally. If you're talking about investing in, I think one of the questions was phishing. We can actually protect people on a personal level. And for the folks on the call here, Jordan and Charlie, I want them to be safe personally. I do want to protect DYOPATH, but I actually care very much about Charlie and Jordan personally, and I want them to be protected. And so that's another way to phrase and to get that point across and say, look, CEO, CFO, CIO, your phishing simulations, they might be annoying for you, but let's talk about how we can make that more specific to your role, to your responsibility, more meaningful to you. And by the way, this is protecting you in the long run too. We want to use dark web monitoring because we want to protect you. We want to use brand reputation awareness. We want to protect you, what you put on LinkedIn, et cetera. So I think reframing some of those conversations, make it personal, make it financial, and I think you'll be successful.
That's fantastic, Sam. This has been really awesome stuff. Thank you for sharing all of it. So to everybody, thank you everyone for joining. This webinar will be posted on our YouTube channel as well as on our social media for you to view. If you have any further questions, please feel free to reach out to solutions@dyopath.com or reach out to sam@sam.bourgeois@dyopath.com. Thank you and have a good day.